All right, we're moving into section 6.3, which is multiplication, division, and estimation with rational numbers. All right, so our first goal is to look at multiplication. Well, we've already seen multiplication as repeated addition, and we can do the same with rational numbers. So here I want to interpret 3 times 3/4 as adding 3/4 3 times. Now above I've drawn a picture just so you or your students could visualize what that means, right? So we're adding 3/4 3 times. If I fill in some of those green sections appropriately, you can see that we've got 9/4, or if I write it as a mixed number, 2 1/4. We can also use an area model. And so the idea here is that if I wanted to do 1/2 times 3/5, I'm going to draw a rectangle, and in one direction I'm going to represent one of the fractions, and in the other direction I'll represent the other fraction. I'll shade both regions, and their overlap is what gives me their product. Okay, so in the first picture I'm representing 3/5. I've drawn vertical lines to break my rectangle into 5 equal-sized pieces and shaded 3 of those. Looking horizontally, I'm going to break my rectangle into 2 equal-sized pieces and shade one of those, that's in the yellow, to represent 1/2. So the overlap here is these 3 squares out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that tells you that the product is 3/10. Okay. All right, so let's try our own. If I wanted to do 2 times 3/4 as repeated addition, well, the 2 is telling me add 3/4 2 times. So I have 3/4 plus 3/4. I have a common denominator already, so I can just add the numerators. 3 plus 3 over 4 is 6/4. And of course that reduces. I can divide numerator and denominator by 2 to get 3/2. If I were to illustrate that, I'm going to draw pies broken into 4s, and I want to shade 3 of those sections for each pie. So there's 3/4 plus 3/4. And so when I combine that, I'm going to take one of the sections from the second circle and fill it into the first circle, and I'm left with 2 sections left in the second circle. And so if you count those up, you can see that's 6/4, or 1 1/2. All right, let's try illustrating 2/5 times 2/3 using the area model. So I'm going to draw my rectangle, and I'm going to do the 2/5 first on this. Whoops, let's zoom in on this side. So I need 5 equal-sized pieces. 1, 2, 3, 4, and that gives me 5. 1, 2, 3, 4, 5. And I'm going to shade 2 of them. Let me grab the highlighter. Let's go with yellow. Okay, so that represents 2/5 going horizontally. And now I want to represent 2/3 going vertically. So I'm going to break my rectangle into 3 equal-sized pieces. And let's use another color. How about the purple? And I need to shade 2/3 of those. So 1, 2. All right, now the overlap, so the places where I have both colors, is my product, okay? So this tells me that 2/5 times 2/3 is 4, and then I count all the number of rectangles to see that I have 4/15. Okay. I'm going to call that the overlap. All right, here's another way to think about multiplication with fractions. So what if instead of giving you 3 times 3/4, I gave you 3/4 times 3? Well, the way we want our kids to interpret that is 3/4 times 3 is asking you for 3/4 of 3. So what is 3/4 of 3? So in this first picture here, I have 1 unit. And I've broken it up into 4 equal-sized pieces and shaded one of them. So this is 1/4 that's illustrated here. Now I just want to keep that in mind as we move down below. So here I want to illustrate 3 units that have been broken into 4. So there's 1 unit, 2 units, and 3 units. Now I want to take that whole, now my whole is all 3 units, and break that into fourths. And that's what these black darker lines are. I'm going to go over them with blue. So 1, 2, 3. Breaks it into 4 equal-sized pieces. Each piece has 4 of those rectangles. And so this shaded region here gives me 3/4 of 3 units. Okay, so what is that made up of? Well, let's count. I have 1, 2, 3, 4, 5, 6, 7, 8, 9 of these equal-sized pieces, which I said were 1/4. So 3/4 of 3 is 9/4. All right. Okay, now when kids start getting confident in their ability to multiply, we can just multiply using the rule. So when I'm multiplying 2 rational numbers, a over b times c over d, I just multiply straight across, a times c over b times d. All right, so let's look at this word problem. If 5/6 of the population of a certain city are college graduates and 7/11 of the college graduates are female, what fraction of the population is female college graduates? Well, 5/6 times the population is college graduates, right? And so if I want to know how many of those are female college graduates, well, I just, need to take 7/11 of 5/6 of the population. Let me make some space so I can do it on both sides. 7/11. All right, so what fraction of the population? It's 7/11 times 5/6, which is 35 over 66. We multiplied 7 times 5 on top and 6 times 11 on the bottom. All right, I'm going to pause the video here. You should do a practice problem and then come back and join me for the rest.